This video is an example for running a hypothesis test for Q to Q. Look at the previous video for all the notes about how that all comes to be. For our example, we're going to look at the cricket chirp example that we've used the last couple of days. And I'll run through everything on the calculator again like before. First thing we're going to be asked for is what is the sample regression equation. You can see in my calculator I have all the data values listed, all 15 data values. Cricket chirps in X, temperature in Y. So we will calculate regression, X for linear, A plus BX, just like we've done before. And I need these three pieces of information. Y-intercept, A, B is the slope, R is the correlation value. So we'll write our equation as y hat equals 25.23 plus 3.29x. Here's my slope, that's what we're really interested in. And we know that the R value, the correlation, is 0.84, which is moderately strong. Next, we're going to look at the three graphs for bias. Now, we actually did this for this data set yesterday already, and we found no bias. I'll walk through that again. So what I see for the graphs is graph 1 I have set up as a scatter plot. Yep, looks linear. Graph 2, looking at the histogram of the Y values, looks roughly normal. Graph 3, do the residuals have any outliers? And no, there are no outliers here. So everything looks good. As far as you know, it's random and independent. So our biases are good. And then we're going to run the test for slope. The hypotheses in terms of parameters and variables. Null hypothesis, beta sub 1 equals 0. It means there is no relationship between cricket chirps and temperature. If I reject that and go with the alternative, that's beta sub 1 is greater than 0. So there is a positive relationship between cricket chirps and temperature. How did I know to use greater than? Well, my slope is positive, greater than 0. So has to be greater than. Give the test statistic if SE sub B sub 1 is 0.6015. So again, we're providing the standard error for you. We're providing the spread. So I'm going to run the T formula, my slope minus what I'm hypothesizing the slope to be, which is almost always going to be 0. It can be other things, but for us it's going to be 0. And then I'm going to take that difference, or 3.29, divided by the spread that was given to us for slope, SE sub B sub 1. And again, that is not typical residual size. The spread of slope is different. Typical residual size refers to how far the points are from the line. This tells you how spread out the slope could be. So if this is my sample slope in the middle, SE sub B sub 1 tells me how far away my population slope would be from the sample slope, potentially. So I'm going to take T B sub 1 minus beta sub 1 divided by the spread, and that gives me a t-score of 5.5. That's big, no matter what the degrees of freedom is, but I'm going to find the exact p-value. Now there were 15 data values. Degrees of freedom is n minus 2. So n minus 2, that's giving me 13 for degrees of freedom. So I'm going to run this through the calculator. Let's show that here. We're going to go distribution T CD, as always, we use CD. And I'm going to have my lower be 5.5. It's a positive t-score. We always go towards the tails. If that was negative, I would flip-flop these and put negative infinity for the lower up to my t-score. But anyways, I have 5.5 for the lower to infinity, degrees of freedom 13, n minus 2. And I can see, there we go, p-value, scientific notation. P-value is 0.00005. So here's my conclusion. Write a conclusion in terms of parameters and variables. Use p-value and r value. If h sub o is true, which means there's no relationship, if that's true, there is a 0.005% chance that the sample slope would have been 3.29. So there's almost no chance that I would have gotten the slope I got if h sub o is true, which means h sub o is probably not true. So we're going to reject the null h sub o, which means we're going to go with the alternative that we wrote up here. So we have strong evidence, p-value is very small, that the population slope is greater than 0, and that there is a moderately strong, and that goes back to the R value, 0.84, moderately strong positive relationship. Now, we are going to be doing confidence intervals for these, but that's for another time. So that's one full example. You have one practice problem that you have to complete. Look at the document that's posted.